Hello, Jose,
Hello,
you
hello.
there? I think we're here
I'm
now.
here. I'm here. Are we here?
Yeah.
Ooh, fuck, we're here yet again for another stream. I'm just gonna pull up the chat real fast. But yeah, I think we're here, my boy. How you doing, Carlos? How's life treating you?
Pretty good, man. Um, I think the main thing is like we're on break, you know.
Yes,
Um,
sir.
don't have to worry about assignments. The only thing I'm worried about right now is that grade, that final
Oh
grade.
yes. The final grades
Yeah.
odds up, but I mean,
Uh,
if they were due yesterday, I think we got it. I think we're good to go. But
well,
you
I
never
hope
know.
so.
But yeah, damn, bro. I
But
like
what
the
you been up
village.
to?
I like the
Oh, I
village.
appreciate you, man. What you been
Yeah,
up to?
pretty
What you been up
cool.
to?
Pretty, not much, bro. I'm just trying to recuperate from what was it, 6 hour gaming session
Oh,
yesterday, Factorial.
do
Damn,
tell.
bro. I mean, I had nothing. I thought, not I wasn't expecting anything from it. I was like, yeah, I'm just gonna play it. Probably play 3 hours, 2 hours. Get a taste. But one thing led to another. By that time, I realized it's 1 a.m. and I'm like, damn, bro. And then,
Yeah.
it's a game that hooks you, right? You have a one little mistake, you fix it up, and then you see there's another mistake, you fix it up, and then you fix it up, and then you fix it up. It's like a domino effect, right? But after I got that green goo and stuff, I was like, I'm
Green
done, bro. I'm
goo.
done. The green Kool-Aid.
Green Kool-Aid.
The green Kool-Aid, I was like, you know what? I'm done, bro. But
Game were
it
you
was
talking
pretty
about
fun. I
again?
enjoyed it. Huh?
What game were you talking about again?
Factorial. If you guys
Oh, okay,
don't know
okay.
it, Factorial. Factorial. It's a really good game. Worth the time. It's it's fun. It's fun. It's fun. I like it. It's a headache, right? Trying to figure out what's the most efficient way. But other than that, it's fun. It's fun. 100%.
Nice.
Yeah, but it was crazy. It was crazy. Yes, sir.
Yeah.
How about you, Carlos?
Well, I mean, to kind of bounce off that, um, maybe not bounce off of it, maybe like to continue what you were saying. Yeah, it was really fun. I knew Jose and our other buddy Mike. They were gonna be new to the game. I introduced it to them. I said, "Hey boys, I have this really good game. I feel like it's gonna be really fun if we all play it." And we said, "All right, during the break, we're gonna play it and hopefully beat it, right?" So yesterday was the day, our first day of playing it, and I was almost like their supervisor. I was watching them build, learning the tricks, learning how to the concepts of trying to make an efficient factory, and it was really fun
Yep,
watching
yep.
and hearing their little brain try to like create the create things. So I thought it was pretty cool. But now Jose's already better than me at the game. Like
Nah, not
he already
even, not even.
took control to make like one of this main system that we need for research, and yeah, so it's
Nah,
really cool to see
it
it.
was fun. It was fun.
But all right, Jose, you ready to get started, man?
Alrighty, I'm ready to get started, brother. Let's
Okay,
get this stream going.
do this. Uh, oh, this music is not. Give me 1 second.
Mm, mm. Hey, make sure it's not copyrighted, my guy.
All right, should be this. Okay,
Yep, yep,
so where are
yep.
we at? Where are we at? So we're still on dynamic
Uh,
programming. If you can see the
mm-hmm.
title, we're not stopping the stream till we solve one. I feel like we've been solving some, yeah, but you know, last one that we did, I think we had some help, right? Wasn't it?
Yeah, we did some help. Yes,
So
yes.
so this time we trying to make it minimum help, and we just want to try to solve one again,
Yeah.
like go through the trenches with the problem and try to figure it all out. So I don't know about you, but which one you like? We got palindrome
Oh,
substrings or decode ways
I
or
think
coin
decode
change.
ways. I think decode
Decode
ways is
ways.
easier and could work as a little warm up.
Okay, little
Yeah.
warm up. Okay, okay. So let's go
Yeah.
to decode ways. Here we are.
Yes, sir.
All right, Jose.
Also, I
You want to
sent you
read it?
the Skelly draw
Yes,
just in
I
case, by
got
the way.
that
Yeah, yeah.
right here.
All right.
Oh, did you
Zoom out a
put
little bit.
the? Okay,
Yeah,
there it
right
is.
there. Yes, 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 yes. Okay, just to make
Okay.
sure. Yeah, yeah. All right, let me read it up. So this is 91 decode ways. It's a medium and it says the following. You have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping, right? 1A, 2B, all the way to 25Y, 26Z. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes, 2 and 5 versus 25. For example, 11, what is it? 1110.6
Oh,
can be
sorry.
decoded into, oh good, oh good. There you go, thank you, thank you. Decoded into AAJF with the grouping 1110.6, KJF with the grouping 1110.6. The grouping 11106 is valid because 06 is not a valid code, only 6 is valid. Uh, Wait, oh, okay,
Oh,
okay.
my bad, my bad.
The grouping, okay, okay, that makes sense. There may be strings that are impossible to decode. Given a string S containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid way, return 0. The test cases are generated so the answer fits in a 32-bit integer. Example 1, we got 12. Explanation 12 could be decoded, well, the output is 2. The 12 could be decoded as AB, 1, 2, or L as 12. Inputted S could be 226, right? And the output is 3. 226 can be decoded as BZ 226, VS 226, or BPF 226. Example 306 is 0. Explanation 06 cannot be mapped to F because of the leading 06. The 06 is different from 06. In this case, the string is not valid. Encoding, so return 0. Okay, okay,
Wow.
okay. Hmm. Let's think about. Let's think about. Hmm.
How did you wake up today?
I woke up pretty tired.
What
Nah,
time?
nah, nah. I woke up at 8 or 7:30, and then I was, you know what? I'm gonna go back to sleep. Fell back to sleep like until 11 or so.
Okay.
Yeah.
Same
How
here.
about you?
Same here.
Same here. Same
But
here.
I didn't wake up at 7 though. I just skipped and woke up at. Actually, no, I did wake up around 8 or 9. Um, because
Okay.
my phone was blowing up. But um, other than that, yeah. Okay, so
All right.
you realize that there are many different ways you could decode. Oh man, I'm tired.
So,
You can decode a message because some codes are contained in other codes versus like 2.5 versus 25. Ah, I see what you're saying.
yeah. Yes, you have to break it apart.
Okay, what are you thinking?
I mean, I think it's.
So you gotta store.
Mm,
You're gonna have to store like that that one is gonna be this two, right?
well,
Or
we just have to check if it's less than 26 because we don't want to we don't want the actual string or the decoded string. We just want the if it could be or how many possible ways it could be decoded.
so if I had the string three and 5,
Mm-hmm.
there's 2 ways that could be decoded.
One way because you got 3, right, which could be B, 5, which could be A B C D E E. So you got B E, but then you got 35. 35 is greater than 26, so there's no letter. We don't have 35
So isn't that
letters.
2 ways
Yeah.
though? You got 3 and 5.
No, that's one way. because it's the entire string. You have to use all the numbers. You got 112 because in the explanation you can do 1 as A, 2 as B, and L as 12. Is you're going based on the number, not on the strings, not on the like how many one can represent.
I'm a little bit confused now. Because
Yeah.
you could
Uh-huh.
oh, I see. Okay, I see. So the full decoded message is
It's
just
using the
converting
entire.
one or two. That's one decoded message, or you could decode the whole thing, which
Yeah.
is L. Okay, so two.
Yeah.
Okay,
Yeah.
okay, yes. So
Yes.
it'll
Yes.
be
Yes. Yes.
one if it was 3 and 6 because you could decode 3 and 6 individually, and that gets you your message.
Yeah.
Okay,
Mm-hmm.
okay.
Yes. Yes. Yes.
Now,
I would say go to Excalidraw, work out the logic, and see for any edge cases and all that stuff.
okay,
Yeah.
we're here.
We're here. Okay. So we got, what do we got? We have 1, 1, 10, 6. Right? What I was thinking, right?
Mm-hmm.
Let me see. No. There you go. Oh yeah, 1106. 06, right? So bro, this is a horrible number. Give me a sec. Space it out a little bit
If only
for
there's
the
like a
viewers.
way you could like type. That's interesting.
I know, right? But I mean,
If only there's like a
no.
feature that like if you could type, that'd be great. Imagine
Nah, it's okay.
imagine if there was a feature on here where you
There you
could
go.
like type in a text box rather than draw. That would be crazy.
There you go. It's understandable.
All right. Close
Yeah, so
enough.
we got 11. Yeah, so what I was thinking, right?
This is a string, by the way.
Yeah, this is string. Yes, this is
Okay.
string. I was thinking of having a for loop that
Yep.
grabs the first one, right?
Okay.
And sends all of this to a recursive call. Right?
Yes.
So you now got 1106. Boom. Send all of this
Yep.
to recursive call. 6. Send all of this. Boom, boom. 06. Bam. Right.
Yep. And then
Like that. And then we have our base cases, which are, I don't know.
if the number is
Well, first, leading zeros. If there's a, I'm gonna use a text box because there's some people that prefer like text box, Leading zeros, we're gonna return false. Then, like that. Boom. I feel like those could be our 2 test cases.
and to know if there's a leading zero.
Wait, give me a sec.
Or if you mean like if it's a zero in general?
We can do 0 in general. Yeah.
Because we can't have any zeros, right? Because it starts at 1.
Yeah. Yes. Okay, so let's think about it.
Is this very similar to that one? We've done a problem like this.
Yeah, we've done a little bit of problem like that. Yeah.
Forgot what it was though. So okay, you break it up. You call recursion. Rest of the list keeps going down. Once you're down here to the last, don't you do the last one, or are you gonna do the last 2?
I mean, we can check if this is valid or not valid, right? If it has a leading 0, we can return a false in here, right? Or Let's think about it. Or we can break it up, like you said, break it up like this, and we got a 6 over here, right?
Mm.
6 is less than 26, right?
Yeah.
We return a true, right?
Yep.
We have a true. But if our valid, if it's this is 0, right?
Then you
And
change
for
it.
littles, we have a false here. We can say, and we can AND them together. And this is gonna return a false, right? So now we got a false over here and a true over here. Boom, like that. Dear name.
So if there's
And
ever
then
a
if it's
0 in the string, that's gonna return
if
0.
it's there's a 0 by itself, if there's a 0 by itself,
I mean,
because we might get 10, right? We might get 10, and that's valid, right?
why
Oh,
is
wait a
10
minute. I
valid?
see what you said. I see, because 10 is less than 26. Yeah or nay?
I see what you're saying. I see what you're saying.
Yeah.
Oh, this is
Yeah.
tough now. Hold up. Wait a minute. I'm looking at
It's a
this
little
right
bit
here.
tough. Yeah, because you have to break it apart. Because one is valid up here, right? Which is this one. This one is valid over here, which is this one, right? And then since this little one, this thing is gonna overreach over here to 6, which we got over here to 10, which this is valid. And then we're gonna have 6 by itself over here, which is valid as well. So that's a 1.
But you can also do this,
Yeah, of course we can also do that. Yeah, yes.
and then this.
Yeah.
Wow.
But the only thing that's stopping us right now is the 0 or the leading zeros. Because like here, the grouping 111.2 is invalid. So how do we determine, or how do we track that invalid case? We need like an if statement where it says like some like I don't know, some like if not the call, right? We kind of like move on to the next. If call whatever, move on to the next, right? Else, return +1, return 1. Or something like that. What do you think? What are you thinking? What are you thinking? What are you thinking?
I'm confused on how this method right here
Yeah.
will also look for these groupings as well.
Well, once it finishes, look, let me erase these things. Let me erase this thing. So we got this, right? Right, 6, boom, right? And then, all right, we got all that, yes. And then we got 10, 6, 10, we got 10 and then 6, right? And then 10, we got 6, blah, 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 we do all that. And then this thing is gonna return back, right? Wait, no. Give me a sec. So we got 10, 6. 10, 6 is gonna return back. This thing is gonna expand. It's gonna say, hey, we're out the limit, we reached the end, or we're over 26. So guess what? Now this one It's gonna loop through 1106. Now this thing gets erased. And now we have 1106. We start from here, we got 6 now. Then 6 returns over here, right? Boom, 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 yada, yada. And then we got like this. Yeah or nay?
Are you saying they made an adjustment?
Yeah. Each
And
of
it does
these.
a recursion again once it makes
Yeah.
the adjustment?
Yeah. Yeah. Then it's gonna be 6. 6 is gonna return. 6 is gonna be like, all right, boom. There you go, 6 right here. And then we reach the end, right? And then over here, the for loop is gonna increment +1. So now we're gonna send 10, 0, 6, 0, 6, 6. Yes, I can. I'll be back.
Okay. So, he wants to break it down. How would you... One, two, three.
Yeah.
Back.
I'm back.
Yo.
I'm back. Yes. Yeah, cause what's your confusion now?
So I get. So are we storing these groups somewhere? Like,
No,
are we
we're not. So
counting how many groups we're
we're
getting?
gonna have we're counting how many valid groups there are, because we're gonna return how many valid groups we can, or valid decodes we can have from these numbers. So we're gonna have like a counter, right?
Huh?
And this counter, whenever there's like a valid one, we're gonna do +1. Yeah, yeah or
see.
nay?
Yes.
Yeah. Yes, we're gonna do a +1, right?
Okay.
And then these ones, and then from here, right? In this iteration, you're gonna see the 10, 6, which is on the example right here on the left,
Okay.
which where we have our 11, our 10, and our 6. So all of this is a 1.
Yeah.
Yeah.
I guess what confused me was how we're gonna regroup.
Yeah, it's just a counter. I was thinking of a counter.
Okay, let's try. Got me scratching my head, bro.
How so?
Just, I'm thinking about factorial now, and
Damn, bro,
I'm hearing
forget
like
about factorial.
I'm
Come on,
hearing the
brother.
machines like in my head running. Did you dream of factorial, by the way? I think a
Nah,
little bit
dude.
I did.
Nah, bro. I
Yeah,
went
like
straight to sleep, bro.
I heard the steam engine like
Ufas.
running, if that makes sense. Could we try a shorter example?
Yeah, for sure.
We're at
Let's
0. So maybe
do.
like I don't know what you would think. Like 30
Let's
something?
do 4 numbers. Four numbers.
Four
Four
numbers?
numbers. That way, yeah. So let's say we got 1, right? Boom, 1, right? We're gonna send all of this over here to 1006.
Uh-huh.
Yay.
Mm-hmm.
And then we're gonna send grab this one, and then we send 06 to another call, like this. Then we're gonna get 0. Then we're gonna send 6, like that. Boom.
George says, hold up, sorry. George
Oh.
says, how did y'all do in finals? I think we did good.
Hey,
I think
we
we
did
did
good,
good.
brother. We did good. I think we're still waiting on
So
confirmation of
waiting
one.
on
But
one class.
we're doing good, brother. How about yourself, George? How's MIT treating you? Yes,
MIT?
sir. Yeah.
How are your finals, George? Yeah, how about that? Or Jorge? Is it Jorge?
Yes, Jorgito Casares.
Jorgito. What's
Yes,
up?
sir.
Anyways, sorry. Yeah, how were your finals, man? Okay, keep going. Sorry.
All right, so you're gonna get the 6, right?
Mm-hmm.
Boom.
Let me
Right,
break
you
it
see how
down.
we're breaking it around,
Yep, yep,
right?
yep.
Now the encode that we have, it's 1106. That's the encode we have right now. Yeah or nay? Because we got a
That
one
is
year,
correct.
one
That is
year,
correct.
10. Yeah. But this
Yes.
thing is invalid though.
Invalid.
Why? Because we have a
Because it's
0.
0.
Yeah. The only way it's invalid because it's if it's 06, right? That's the only reason why
Well,
it's
is it
invalid.
invalid though? Because 1 is a group. 1 is a group. Oh, wait, no. This could be a group. Oh, I see what you're
Yeah,
saying. We did
well,
it
in this
individually. So we're not there yet. We're not there yet.
individually,
Okay.
yes, yes, yes,
Okay,
yes. We're
okay,
not yet.
okay.
Yeah, yeah. This is a
Yep, yep,
decode,
yep, yep,
right?
yep. Mm-hmm.
So I think what the problem is saying when you get 06, right? The next step of breaking it, this is the problem, like what's in trying to emphasize, right? When you break it, right? You have, like, for example, you have 06 in here. When you break it, you get 06 separately, right?
Yep, yep, yep.
This 06 is the same as this. You're gonna get the same case, right? So that's where you kind of catch it beforehand, like, hey, if there's a leading 0 in the
And
number,
just the rest
just like
is, yeah.
exactly, yeah, X out, because the next step you're gonna get a 0 and the
But that's
6,
only
which
if
is invalid.
that's only if there's 2 digits. If there was another 7
Uh,
right here,
well, yeah, that number 7, it's still invalid because, right?
no,
For
but
example, let's say we had
it would be invalid for if it was this, but not if it's this 6 and 7.
like this.
Yeah, like
Well,
what I'm
this
saying
still
is
this
this will be invalid,
okay.
but this won't be invalid.
Yes, that won't be invalid, but the 0 makes it invalid though, because it can be decoded. We don't have a letter at position 0. We just have 1. So it can be decoded
So
because
you're saying
it
the
could
whole
be
thing can't be decoded.
the whole, yeah, exactly. The whole thing is invalid.
Okay, so if there's a single 0
There's a single 0 or a 0
or
or a leading
0,
or just an overall leading 0, that's false.
okay. Jorge said, "Oh my god, I'm a disgrace, man. Sorry." Jorge said, "I only have one final left on Thursday, which is design and analysis of
Oh
algorithms. I might get a C." Oh man,
no, brother, no. Keep strong, brother. Keep
you need to
strong.
stay
You got
strong,
this.
man.
Okay, stay
Your
strong.
finals aren't done. That's crazy.
Yeah,
This week, you got it, man. Come on,
you got it, bro. 2 more days. 2 more days. 2
2
more
more days.
days.
Let's
2 more
go.
days, and you're done. You're done. You're free. Damn. Okay, so
So if there's a
so
singular
that's
0, we could say the whole thing's invalid.
yes. If there's just a single 0, but when there's a 10, that's
It's
not
not
invalid.
valid.
That's not invalid. Yeah,
Well,
yeah,
that's what
yeah.
I'm saying.
So
Is this group right here
that's
and these
valid.
groups will be valid.
That's yeah, that's valid. Yes. But the only reason when there's invalid is when the 0 is in front of a number. 06.
Yes. Yes.
That's
Okay.
the only reason. Yeah,
And since this is invalid, it'll make the whole thing invalid.
exactly. Yes. Yeah.
Okay. Okay. Okay.
Yeah.
Okay. Okay.
We don't count it. We don't count it.
We
But
don't count
another
it.
combination, yeah, we
There
don't
might be
count
another
that
combination
combination.
though.
Yeah, exactly. Yes. 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 So now my question is, how do we track the 0 or 6? How do we like how do we know, or how do we add the numbers? Does that make sense? How do we give get a counter, or have a counter embedded in this? Come on, brother. We're almost there. We got the logic. We got the
So
logic. We got the logic.
if it's valid,
I
hold.
would say to return a
I
true.
got you. I got you. Ready? Ready?
Okay.
If it's valid, hold it true, like you said. If it ever becomes invalid at one step, then that means
Return
once you
false.
reach the top, it returns false or whatever, and then it won't get counted. So the counter is
Okay.
only going to be in one step, like maybe the top step, or and it
Oof, that's
says
gonna be hard.
is if it's false, then you don't increment the counter. If it's true, then you increment the counter. But it only happens if it passes true all the way up here, because that means it was valid, it was valid, and it was valid, and then boom, that's wait. Yeah, so that's one single count. That's one single.
Yeah. It's because the thing is, now my problem is, right? You said we can only have the counter in here, right? But since it's recursion, right? We're also gonna have it here. We're also gonna have it here.
I see what you're saying.
So that's easy. That's where I'm like, how do we keep track without incrementing the uh the number of counts?
So what was the process again on how it's gonna shift over again?
It's just like a loop. It's gonna shift 1 to 11. This is gonna 11 pass in 0, 6. 0, 6 is gonna be broken down. Then we have 11, 10 pass down 6. Pretty much. This is gonna pass down, and this one is gonna pass down to 10 and 6. In that pretty, like it just moves one to the right, pretty much.
So eventually it would be this as a whole.
Yeah, this is a whole. Yeah, but since this is out of bounds, like you can't have. We don't have 110 letters, so this is gonna be false.
So is it fair to say that we can never get more than 3 digits?
Yeah.
So then why would you loop all the way over here? Like why won't you
Well,
just
I mean, we can
boom,
just check if
boom,
26.
boom?
Check if it's like if it's less than 26, keep going. If it's greater than 26, just return false.
This is not how I wanted to start my day.
Come on, bro. Hey, come down, bro. Come down, bro. Hey, take it easy. Take it easy. Take it easy. Take it easy. Yeah, but checking if it's less than or greater than 26 is the same thing as checking if it's 3 digits. And I think checking if it's greater or less than 26 is better because we might get 27, 28, 29, 30, 40, 50. They're not 3 digits, they're 2 digits. But we don't have letters. We don't have 50 letters. We don't have 30 letters. We have 26.
Hmm.
So
Okay.
checking the range is better than checking the amount of digits that we have.
I think I'm catching you. I think I'm catching you.
Yeah. So this is great. I like this logic. I think it helps. It works.
Okay.
But now it's keeping track of the counter, right? Checking like, all right, we have an invalid one. We go up, check if it's invalid, return invalid over here. Well, that's the thing. We cannot return
Ah,
invalid from
I
here
got
though.
you. Maybe. Maybe I got you.
Okay.
So this is a function, I believe, right?
Yeah, it's a recursion. Yeah.
Inside the function, oh. You have a for loop
That loops through the digits.
that passes part of the digits that runs the function. That passes part of the digits into the function that runs it. So whatever returns out of this function right here in the for loop box, which is outside of the recursion, you change the counter. And the for loop is adjusting the the next. Now the next one is
Okay. I see you. Okay. Yeah, I get you. I get you.
something like that. Where
So you're
the
doing a
the
for loop to call recursion.
the for loop to call recursion, but the for loop is gonna pass the parameters into the recursion call. Does that make sense? I think so. I
Yeah,
think
it
it
does.
does.
It does. It does. It does.
So you have the for loop, and then you call the recursion with this, and then you put the digit the
Well, I was
digits.
thinking of putting the for loop inside the recursion.
But I know there will still be a for loop in here that runs like in the recursion because it's gonna break it down like this. But what it won't do is it won't auto shift. It won't shift like that. That's what
So
this
what
will
do we need
do.
a for loop for?
The for loop is gonna. Oh yeah, no for loop then. Oh, no for loop inside. It will just call the recursion
Mm,
while minusing or something like that.
mm,
And that's why whenever this returns or however it works, then you say um, if if blah if blah then counter plus equals 1, and then yeah. For
okay,
loop.
so let me see. So you say there's no auto shifter, right? How are we gonna shift this car over here? Because this for loop only shifts this one over here, right?
Well, not it's
But it won't
gonna.
shift this one here nor this one over here. Because yes, we can shift it to 11, then we can send 06, 06, right? We're gonna, but what if we have like another number over here, like X? Are we just gonna send 06X? And then how can we get the value of, I don't know, 10, then possibly 106, and then X?
Hmm.
Or, wait a minute,
Wait a minute.
wait a minute, wait a minute. No, it's because that's the thing. Because I don't know how are we gonna keep the counter. Because that's the tough part. Because we can say like if true, right? If true, right? Which represents this represents our value of our car, and car, right? Counter plus plus. This thing's gonna return a 1. Hmm. Damn, I don't know how to do this one. I didn't get this far. What are you thinking, Carlos? What's your status? You know
Memory.
what? Let's start with 12. Let's start with 12. Let's start with something small, right? I think we're biting a lot that we can chew, more than we can chew. Remember, if we can solve it for one problem, we can solve it for the rest. Let's start with 12. Boom, 12. Easy as that. 12. Right? Or no, 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 not 12. It's going to be
Okay, we got 12.
So we got 1, right? We send 1 and we send 2, right? We check if it's valid. If it's true, we send T. If 1 and T are, if 1 is valid and 2 is valid, we send a +1, right?
+1.
So 1, we check if it's true, it's valid. And 2, we check if it's true, right? So we have a +1 here, right? And then we send 12. We send 12, right? We check if it's valid. If it's valid, with a +2.
What do you mean you send 12? Like you're sending it
Well,
into the function?
we don't send 12. We just check 12.
Now, where are you gonna put that at? That check?
Well, we can do an if statement if we call it cur something current, like if cur val is less than or equal to 26 and greater than or equal to 1.
0. Oh.
Yeah, like this. If that's we can say true, right? Then if we can call this cur status, maybe, right? We gotta say if cur status, then we can do ca.
Hey, you're copying me, man.
Right? What do you
No,
mean?
I'm joking.
Ca. You can say counter plus equal 1, something like that. So like if we know that 1 in this case, for example, let me spread this a little bit over like that. For example, this 12, we're gonna send 1, right? 1 will go in here. If curve value, that's true, status is true, right? So we got a T in here. We got a T right here. Then we go with the call, which will send 2. 2 is a call. Then we go in here, curve status equal true, right? If the curve status is true, we return. All right, we're gonna return true in here somehow. So this true returns, boom. So now we got a true in here. So we have true. So that's a counter +1, right? And then we send the 12. We check the 12. 12 is status is true. We check if we are out of bounds or something like that. We have a check of if we have more digits. And if we don't, and it's 26, we have a true, and then we add a +1. So we get a 2 right here. I don't know if that makes sense. Yeah or nay?
So if it's true,
We have to have both trues. 2 trues. We have to have 2 trues. Like if the current status and the call, right? That's a counter +1. But if we are outside, if we are at the end of the string, we check if the entire string is inside the range. If so,
how do
we
you know if you're
return
at the
true.
end of the string?
Well, we just check the length. We have a pointer. A pointer is gonna be the for loop. So for example, let me see. Let's write it out. I'm on top. Let's say right. We have right something like that, right? Then we check. Uh, mm, So we check that, right? So here we're just checking if we're taking substring 0 to 1, 0 to I, right? 0 to I, which is the number we're trying to, the current number we have, right? Check if it's greater than 1 or less than 26, meaning that's in range. Yeah. Yeah or nay?
So
Yeah or nay?
this is for.
This is a for loop. That's just a for loop looping through the string.
So this is at. Let's say this is at 1, right? This is at 1.
This starts at 0.
0. Check if substring.
0 to I, which is 1, right?
Okay.
Checks this thing is 1. If it's greater or equal to 1 or less than or equal to 26.
And then it returns true.
Yeah, it gets a status as true, right?
Okay.
Right. So that's great. Good
Like
stuff.
this. Now that it's true,
Yeah.
we're still in the loop. What happens?
I don't think we're never gonna leave the loop until the end. So now we're
Okay.
going to check if cur status and call, right?
Let's call.
Call is a recursion function, the recursive, right? We're gonna send the recursive, right? If they're both true, we go counter plus equals 1,
But this is
right?
gonna have her
Yeah,
val what?
it's gonna send the substring of 1 of I all the way to of length of curval. Boom. So this substring represents the 2. So we're just sending the 2, pretty much. Yeah
Yeah.
or nay?
Yeah,
Yeah.
that's really nice.
Here we need another one saying if I is at the end, if I is equal to the length, right? And we have to check if the substring is still valid. Counter plus equal 1 and return. Boom. So
And
this last check is to check.
else what?
I think that's pretty good.
How else is it gonna return?
What do you mean return?
Like what's the other? How else will the code return? Like this is only if it's true right here. So what
Yeah.
if it's false?
Yes. Well, we continue to this one.
And then
We
what
come
if
to
this
this
is
one.
false?
We continue to this one.
But there's nothing more, because it's already I is at
Whoa.
length.
This is true. This is false, right? So this is false. This is gonna go. It's not gonna even go to counter plus equal one.
Okay, so it's the instance or whatever you want to call it. It's just gonna
Yeah.
return automatically, or
Yeah, I think so. We're gonna have a counter status of false, like a default value.
what I'm saying is like this is the only way we're gonna return something. So what's the other way we're gonna return if it's false? But do we need that or no?
What do you mean return something?
Oh, give me a second.
Yep.
Oh, give me a second.
Yeah, thank you.
Like this case right here. If I is at length, is at the end. Right?
Yeah.
And it's valid, that's when it's gonna return. But I'm wondering if do we need another return for a case that it's false? because how
Yeah.
else will it
Yeah, yeah,
return?
yeah, yeah. We're gonna yes, we need the base cases. If substring 0 to I is not in range, or we have a leading, or 0, or it's not in range, or we have a leading 0. Return false. Return true. Like that.
Okay.
But we still have to figure out the counter issue.
Hmm. Will this be uh hmm. Equals true, pass through this. Are we returning? Don't we need to return true right here? Uh,
Where?
right here.
Yeah, we can return true there.
Okay. And then what's this variable right here for?
This is for to keep track of the current status.
Yes, yes, yes. If
I mean, I don't know if this is going to work. I feel like the logic's very. We deviated from the logic because we
I
still have
mean,
that issue of the counter.
but
'Cause how are
but
we gonna?
but now we could see a, a coding visual of it. So where maybe we could find an exact place to put it rather than with the what we had down there. It was like graffiti.
Yeah.
Graffiti. Ha 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 ha. Very interesting.
Yeah. Then we still have to make it dynamic
Yeah,
or
this is
memorization.
just a recursion part, right? Or recursive.
Yeah.
It's just a recursive. Oh man. Recur. Put our problems right here.
Let's see. I'm gonna go to the restroom real quick. I'll be back. Yeah.
Okay. Interesting. So if it goes down, let's say we're at sample. If we got a string that is 152, let's see, and then you break that down to where we only get, let's see, for I in range length, so we're at I, which is 1. And then the rest, just 5, 2. Other that. Current status equals false. If I is not in range or leading 0, I is in range. If I is not in range. Okay, so the length would be 3. Length is 3. So if I is not in range, I is 1. So it's less than the length, so we're good on that. If I equals length
Yeah. Yeah.
and
Yeah.
substring, what's up? What's up? What's up? I'm just trying
I get.
to
I get.
trace it real quick.
Yep.
If
Yep.
I equals length substring, uh, it doesn't equal length, okay. And then check
Mm,
if I, okay, perfect. So true. Curse status, true, and recursion, it goes to 5. So wouldn't it be like where this is? Boom. 2.
Yeah.
If that's ran, then it's gonna start from the top again. We're at 5. 5 doesn't have a leading 0. What do you mean right here when it says I is not in range?
Like it's outside 26. Like it's greater than 26.
Might make an adjustment real quick. Tell me what you think. Oh. Okay, so this is. No. That means we could delete this. Yeah or nay?
Let me see. Is it the same?
Yeah.
Yeah.
Like we deleted the extra code on the second if statement. That was checking to see if it was in range.
Oh, okay. Yeah, that
Right?
makes sense. Yes,
Okay.
yeah.
And
Yes.
then check if substring 0 to I.
I'm trying to see how.
Else. There you go. All right. You have curse
Okay, let's see.
status. I mean, this one could just even. You could even just do. I have another question. Whenever we're calling this recursive function, like at the last line in the condition,
Yeah.
what are we passing through again?
We're just passing the other part of the string, like 5-2.
But how do we pass that? We pass
just
that
get
by saying
the as
I
a
plus
substring.
1.
Well, it's a string, so we'll have to do a little bit of like string manipulation
So you're
to
saying
get it.
cur val from 1 to the end. Like, I don't know
Not
if it
quite.
updated
From I.
from I to the end.
Yeah.
But aren't you trying to get the thing next to I?
Yes, because I is gonna be at 1. We need 5 and 2, so I
So
plus
what?
1
I plus
maybe.
one. Okay, I plus one, and then I'm just gonna put. Tell me if that looks good. Uh,
Uh huh. Okay. Yeah.
then I'm confused on this counter right here. So basically, what I'm doing is I'm trying to replace this last line and put it into this
Yeah.
if else because
Mm, mm, I mean, you need to update current status because if you want to put in the if else, you have to remove the status, the curse status,
yeah, I was kind of
which
just
will
we
which
don't
you can
need
delete it because
we don't need
we don't need it. Yeah,
yeah.
we don't need it. Yeah. So it would be that, and then we just call it the you cannot delete this.
But then where would we put the counter plus equals one at? At the that was at the bottom.
Right here, plus equals or something like that.
Ah, oh, really nice.
But
Okay,
I'm not sure.
now let's trace it.
Wait, give me a sec. Give me a sec.
Okay,
Give me a sec.
do your thing, do your thing.
Because we still have to return something. With your cursor?
Yes.
Mm, let's see. Let's see the problem. What's the problem? Or let's try it out with 226. It's what happens if we return 1 right here, right? Let's see what happens in here. Yeah or nay?
The 226.
Yeah, 226. Let's see. It's because you know what I don't like about typing is that you have to
Yeah,
there's a lot
copy
of
it. You gotta
like
formatting stuff.
yeah. Exactly. That's why I just like writing it. It's not so much like because it's more like you have to go in there, blah 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 blah. Eh. So, but I'll do type. I'll type it. I'll type it.
You do whatever you like. It don't matter to me.
No, I got you, but I got
I just like
you. I
joking
know it
around with
matters to
you.
you. I know. All right, so we got 226, right?
Okay.
So we got 2. And we send. Oh, there he goes. 6 6. Like that. Boom. Right. Then we're gonna delete this like that. Like this. Urinate.
Yay.
Yeah, so this 2 is get if not in range. So there's no leading 0. If not in range, it's in range.
So
So
let me figure something. So this is I right here. I.
yeah.
So this is I currently.
Mm-hmm.
Okay, keep going.
Give me a sec. Give me a sec. Okay. Let's see. Let's see. So we got that. Now we have 6 6. Then we're gonna send 6 in here. So we send it. We sent 6. And then we broke 6 into here. Here or nay?
So this was I. This was the next I right there.
Mm-hmm.
Oh. 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 Ah. Okay. Okay.
Just Control Z. Control Z.
That's okay.
Yeah. Okay. So we got
I'm
6 right there.
6, and then it's not, it's in
6 is
range,
going.
no leading 0. I is not equal
It's
to
a
length,
length.
so else.
It is a length
I meant
though.
this one right here though, the
Oh,
one before, yeah. And then else counter plus equals equals whatever. So now we're at
so we said 6.
this one. So I is that. I is not in range. No leading 0. Okay. I is at length. Perfect. Counter plus equals 1.
Okay. So here I don't think we need counter because I think I know why. I think I was getting too confused in the counter. We Yes, we don't need a counter plus 1 here.
Okay.
Oh, because it's
You
locked, right? Yeah,
return
I'm locked.
1. So this will
You
turn
return
into a
1.
1.
Yes, this will return into a 1. Yeah, so 6 will return 1 over here.
Okay.
1, right? And then, right, 1, and then, right, so let's see, how do I do this? So here, we have a 1 in this place, we have a 1,
Yep.
right?
We
We
have
have
a
a
1.
1. I'm gonna put it next to the call over here. 1, right? And then we can delete the 6, right? And we move the comma over here. So now we got 6, 6, right?
Because this changes right here, right? The I in
Let me
range.
see, let me see. Yes, yes, the iron range
Okay, so
switches, yeah.
now the I goes like you said, it's over here.
Yeah, 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 yeah.
Okay.
So we still have that 1 though. We still have that 1.
We still have the 1. Yep.
So counter over here
Counters on
is
the
counter.
outside or
Yeah,
oh
counter is
sorry, I
still equal
locked it.
to 1 right now.
Now where's
Count.
our counter decline declared on the outside?
Oh, give me a sec, give me a sec. Lock. Oh,
Oh,
there. I'm gonna delete these so we can Okay, there we go. My bad, Obi. There we go. So, okay. Let me think. We can do it right here on the for loop. Inside the for loop. Inside the for loop, we can just say call counter plus equal 1 or something like that.
but where's our
No,
counter
no, no. Outside,
defined?
outside,
Outside.
outside,
Okay.
outside, outside, outside in the
So
for loop. Yeah, right there.
counter
Yes, 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 yes.
equals blah blah blah.
Yes, yes. So yeah. So now counter equals 1, right? Because of the previous one where we had the 6 over here.
Yep.
Because we had this one is 2, 6, 6, right? That's one way, right? Now this way we have is 2, 6, 6. Yeah or nay? Because we got this one right here and this one right here. We got 2 and
Yes.
6. Yes? Okay.
Uh-huh.
2 and 6. This 6 goes into here.
Wait,
If
wait,
it's out of
no.
range,
Actually, no. Nay, nay.
uh-huh.
I'm confused. Is
Wait, this is wait, give me a
is
second.
what I'm confused about is how does moving this over mean that it's gonna be these two?
Because now look at your substring. Your substring, we're gonna have a substring from 0 all the way to I, right?
That's not what I put here.
Well, this is you're calling the recursion right here. We're not calling recursion anymore. We're going here. We're gonna have digits. We could do substring of 0 all the way to I.
Oh, so
Now,
we didn't have that in
or from
place.
I, or from I all the way to, wait, not to the end. Uh, Yeah, we need a curve. I'm not sure about the substring. No, I think I know. I think it could be from I. Yeah, because we need to keep track of what the current value we have right now, right? So this is I. Hmm. Because I think we're damn.
Right?
This is rough.
Like that's what um like just because we moved it over doesn't mean we're using these two.
No, we are using. Yeah, I mean in the code, yes, but we need to use these
We
two
need to
for
use
sure.
these two though.
We need to do. Yes, we need to. Yes, yes,
Mm.
yes. Well, we can do zero then, because we can just pass in substring, if I'm not mistaken. Mm, mm,
Wait, why did we already return one again? One means that. Oh, okay.
yeah. We need to fix up these because we're only returning one when we're on length,
Yeah.
so we
Dang,
have to fix up
nabbit.
that.
Let's see.
Yeah,
Okay, okay.
we're getting there.
So I was this. We broke this down. I was this again, and then we broke it down to there was another six right here, right?
Mm-hmm.
This six right here returned one or yes, returned one, which then came to over here,
Wait a minute. Wait a
which
minute. We
is
don't.
this. And then we said counter plus equal we said counter is one. We added one to the counter. But is that so when we're going down, we're already checking if it's valid. So we're checking,
Yeah.
okay, 2 is valid, 6 is valid, this one's valid. All right, bet. Return 1. And the next one, when it goes up, it does this. And then
Yes.
return that.
So yeah, I was getting confused with the counter because I was saying, well, we have to keep track of the counter on top of here, but no, because we can have because this six can give us like three different ways of how to do those. So we just have to add them up on each level. I don't know if that makes sense. That's what we can do counter plus one. And we can do
Well, the thing is, it's going to get tricky because this it returns the 6 that was down here.
yeah.
It returns up here, which will give counter plus equals 1. And
Mm-hmm.
then now where we're at for this call is we were
Mm-hmm.
right here. So once we finish the else, there's nothing more left. So then I changes. So now
It's
I
over
is over
six.
here, and
So it's
then
66.
well, no, it's just this.
Well, essentially, we need
We
with the
need it to be
substring.
this, but
Yeah.
right now it's this. So then if I not in range, and then I equals length, which that's also wrong. First of all, because we need it. Oh no, no, sorry. Not in range. We need to check if
I mean,
I is that. Wait. Yes. Sorry.
no, we have to
This is
check
right.
the. Yeah, this is gonna hit.
So
Yeah,
this will hit, and it will return 1,
yeah, because it's at
which
6
then
right
will
now.
bring 1 over here again. Counter plus equals 1, and then that's already wrong. I think that's already wrong. I think.
Okay, so the problem here is that we're just checking 6. We're not checking
I'm not
66,
checking. Yep.
right? So, uh, so I, so In case I see her, we're sending this over, right?
Dude,
Mm,
you're right. You're right. We almost I think we almost got it because
yeah,
if
because
this checks
if
this
this,
correctly, then it will be
it's
valid,
it's
and
gonna
then it
return.
will return +1 since we already checked this. This is valid already. Because remember when we're going down, we check if they're valid. So if
Yeah,
this returns 1, and then boom, and then now we have 2 options, and the last bit of it would be if we move over. Oh damn it! I already lost it.
no,
But
it's
yes,
this.
we're
If
almost there.
we
We
get
almost got it.
66,
If we
if we
get
get
this,
66, this is
then we're
gonna
almost there.
return. This is gonna go like this. Boom, right? And we return our counter. We don't return false. We return our counter the way it is, right? Because if it's out of range, right, we can add +1, right? Or we can go further. If it's out of range, it's already invalid. The entire 266, it's invalid, right? So since our counter, assuming we get 66, our counter, which is 1, is going to go over here, right? This, because right now counter is 2, is 1, right? Which is going to send over here. Yeah or nay? Because the only way, if you go back to our examples here, where over here, the only way is this 266. Boom. This is the only way, right? That's the only valid integers, 266. Yes or no?
Yes.
Yes? 2666 is out of range. So this is 0, right? Since this is 0, we're not adding or changing counter. It's already invalid. Dear nay.
I think so. I just have a question.
Yeah.
Is returning counter? We don't have a counter in this,
Well, we have it over here though.
but that's outside the scope of the for loop.
It's inside the scope of the for loop because it's outside.
But we return counter.
We return counter, which already got updated by this call. This call updates the counter +1 because if it, like you said, it's 266, right? 266, that returns 1. 1 comes in here, updates counter, so counter now is 1, right? We get 266, and now the occur digits is 66, right? Assuming we do get the substrate, we get 66 right here, right? 66 comes through here, hey, it's out of range, return counter, which is already 1 from the previous call, from the previous substring. You're an A.
No, I lost track of you. So
All
I'm
right.
gonna break it down real quick.
So,
If I'm
okay, so
understanding correctly,
imagine,
imagine we had this.
wait.
We did this work perfectly.
Mm,
Imagine this worked perfectly.
yes. Yeah.
Okay.
We already have a 1 in counter. Counter
We're
is equal to
going
1 already.
to counter equals to 1.
Yes.
If this works
Yes.
perfectly, this will return 1 as well because we already know this is correct, right? We know everything
Yes.
above is correct. Everything that we gathered above is correct, right?
Yes, because it went.
Not
We already
including
went through.
this. Not including these.
We already went through these.
Yeah.
Yeah, we already went through these. Yes.
So if this is correct, then that means you're gonna return 1. So now counters 2. Correct?
Counter
Counters 2.
is still 1.
But it needs to be 2.
Wait, why 2 though?
Because this is correct. So this one will return
6 is not correct.
6 is not correct?
No, because it's outside. Remember, we don't have 66 letters. We only have 26. It's not in range.
Okay. So this will return false or whatever. Return
It's,
nothing. Return counter
Mm,
what we already have.
it returns counter, which is 1. Yeah.
Okay. And then this right here, this
Mhm.
one will move over.
It's gonna move to 226 to 226 right here.
That
This
just
2
moved to
because
26.
we already did 2. Now we're doing to 26 exactly. We're doing
Okay.
26.
Perfect.
Yeah, and then we're
And
sending
then
6 already.
and then
Uh-huh.
we're setting 6, and then that's when the memoing comes into play. But anyways, I'm gonna
Yeah.
ignore that.
Yeah,
I'm gonna
yeah.
ignore that.
The
So
yeah,
then you
yeah.
break it down
Yes.
again and same
Yeah.
path. Okay, I'm
Same
back
path.
with you. I'm back with
Yeah.
you.
Okay.
Yes,
Yes.
yes.
Now, yes. Okay.
And then after all that, it will go. It will do the larger number, and then you still have a check saying that's out of range, so you're
Yeah.
not even gonna
Exactly.
bother
Yes.
to go
Yes.
down.
Exactly. Yeah. Yeah.
Okay,
And
perfect,
over
perfect.
here, we're going to return at the very end, right there. When we finish already looping, when it's 266, right? Whether at the end, right? Boom. Okay, so this one.
I want to give a little break real quick.
Yep, yep.
Sovic said, love this whole thing. We
Hey, thank you,
appreciate
brother.
that.
Thank you. Thank you.
Sovic.
Appreciate it a lot.
Salvic. Sorry. I don't know how to
Bro, I'm
pronounce correctly.
hungry, bro. Hungry.
Come on now. Come on now.
Hey, thank you, brother. Thank you for tuning in. And hopefully you stay and you like this stuff, Yes, sir.
So where are we at? So
So
what's your concern now? We just need to get
now,
this substring thing set up.
wait, we still a little bit. Wait.
Okay.
Before we do that,
Before we do that,
once we reach the end, right?
once you reach the end,
266.
yep.
It's outside the range. I is length,
Oh,
right?
uh
Which is gonna
huh.
return 1.
Which we
I'm not sure
can't.
if that's wait, no. It's already in range, so this is gonna exit out and we're gonna return counter.
Okay, okay,
Yes.
okay.
Okay. Let me see. Another okay. What about if it was 26? Let's say we don't have this 6 over here. 26. Wait, no, that would work too. That would work too. Wait, no.
Like it was just
What about
26.
yeah, 26? Because 26, right?
Well,
We're
you
gonna
break down
send
2,
2,
and then goes to
break down 2.
6.
6 is gonna be 1, right?
Valid.
1,
1.
1. Yeah, so we
And
got
then it's
one way.
gonna
Then we
shift
got
over 2 to
26.
6.
Then 26 is in range. I is length, so it's gonna return 1. This is not good. Because we have 2
That is
ways
true.
now.
Yeah.
Yeah.
Well,
So
the
what if
reason why we
we
had this 1 is because it's assuming that whenever the call ends, it's gonna be right here. So it's gonna be counter is gonna get added. But since this is literally the only call that we
yeah,
have,
exactly.
then this is not going anywhere. Like you can't.
Yeah. What if we
So
just return counter plus 1?
+1. Gosh.
Okay.
Wait,
That looks
wait,
good.
but that might bring that issue, like I just said, is that remember sometimes over here, down here, if you just have a 6, I is at length, right?
If
Let's
you
say
only
6.
have 1 6?
If only have 1 6, yeah. Ignore this stuff.
Okay, okay,
I
okay.
is at length, right? Or is it?
Well, yes, it's at length, but counter 0 for that call. 6 will have a counter 0 when it's being called. So it's 0 plus 1, right? So we're just returning 1. Because each call, each
No.
time we break it apart, counter is gonna
But
switch.
look, I can see what you're saying, but I think that this will run this right here. Counter
Yeah.
plus equals 1.
Mm-hmm. Mm-hmm.
Whenever it goes back up, it's at this part right here.
Well, what's counter? Counter is gonna be 1. Recursion is gonna return 1. Because this thing
So
value
then you're adding
we're
1
returning 1.
again.
Yeah.
So it will be at
For the
2.
counter, it's because it's not the same counter for each of the calls. It's different counter. Like, it's not the same counter throughout the entire recursive call. They're different counters. For example, let me see if I can delete this real quick. Let me clean this up. Because I think I know what you're saying, right?
Mm-hmm.
Let's forget about this part, right? Right here. Boom.
Okay.
Let's forget about this part. Boom. Like that. Yeah.
Yay.
So we got 2 6, right? 6, this 6, right? Counter this 2 6, this 2 has a counter of 0. 2 6, 6 has a counter of 0. When it hits this part right here, counter is gonna equal +1. So now
This one.
counter is equal to 1. Yes.
Yeah.
This 1 gets transfer over here, and it's gonna say counter plus the return value, which is 1. So now counter is gonna equal to 1, and that's all. Right? And now we finished with 2 6. Now we are at 26. Right? 26.
I agree with that, but the problem is that we have counter outside. So this is going directly to this. Yay or nay?
But look at the recursion call. Would counter, if it was outside the recursion call, then that would be a problem. But since it's a counter is inside the recursion call, each call you do or you make, counter resets to 0, resets to 0, resets to 0. Yeah. So even though you add to counter, you adding counter to that call, the counter of that call, not to the other calls.
I think I see what you're saying. Yes, because this is the whole thing, and this is calling the whole thing.
Yeah,
okay.
Exactly. Yes, but if it was a global variable over here,
I thought that this was calling just this for loop.
Okay, no, it's calling recursion. Okay. Yeah, recursion. Yes. Yeah,
that makes sense.
So
this is getting reset each call. This is getting
yeah.
Each different call. So this one gets added to this, and then
it returns counter plus 1.
It to this one, which is 0, and then it's gonna get +1, and then
+1. Yeah, and then when it gets to 26, it's gonna be 2. Yes. Okay.
Perfect.
Now for the bigger issue, the substrings. How are we gonna deal with the substrings?
Oh yeah, I forgot about that.
Hey, we're getting there. I
like to visually see it. So.
Hey, of course. Yo, give me a second, bro. I'm going for my chancla, bro. I dropped it.
Yo.
Yes, sir.
So currently, the way we have it is that I gets moved to the right.
Yeah.
But we need I to be right here. And then to expand
it's because the thing is, how are we gonna send it? Are we gonna send it as an array? Because if we're sending this these 2 6s as an array, we can just set it as a 0.
Oh, we gotta do it as a substring. You know what I learned? I've been doing like research on Golang, right? On like its syntax, and they don't have dynamically created arrays. Like they're all set, right? But the way you can modify arrays or adjust the size is using slices.
Okay.
And slices is just like substrings. Like you create new substrings of that array that will have a certain particular window that you want to mess up, and if you modify that particular window, it updates all the main array. It updates the main array as well.
Okay.
So I don't know where that applies to this, but it kind of reminds me that you create a slice of this little substring, and then anyway, sorry.
Yeah, I mean we can send it as an array.
I'm stupid, bro.
No, you're good, brother. You're not, bro.
Just yapping.
Good. Wait, we're almost there. We just need to figure out the substring.
Okay.
I'm happy we finished the recursion part.
Yes.
I'm happy with the recursion part.
That's the thing is maybe it won't allow us to, because remember, it will. Whenever you run the test, it will time exceed or whatever.
Yeah, but we can do it with the run, which is the simple run with simple test cases that we have.
Okay.
And if that works, next stream we might get the dynamic, but we'll see. Okay, so we got 6 6. I think we can get it as a substring. send this part as an array, right? All of this is an array. Once we
I was
send all of this,
thinking,
we set this as a 0.
if I is at length, right? Then just get the
Uh-huh.
like if I is at length and we if I is at length and we already have the
Ooh, okay.
computation of 6 stored somewhere. All right, hear me out. Then that means you need the substring.
Okay. We got Jorge with some insight.
Oh,
He said, you can solve the problem without a for loop inside the recursion. Hmm. Hmm. How are we supposed to do that?
yeah. Yep. Whatever you said, I said that too.
Hmm. That's an interesting take, though. Because recursion is a for loop. And Jorge also said the worst case runtime is Tn equals to n times Tn minus 1, which solves the Tn, which equals O of n factorial, which equals to square O of squared n times n to the n, which is very slow. Yeah. Yeah. Our solution is very slow. If you put it that way. Yeah. Damn, Jorge. Got us
Appreciate it,
thinking now.
Jorge. Appreciate it.
Appreciate it. Appreciate it. You got us thinking now. You got us thinking now. Hmm.
You make some
Okay.
food, man.
You're hungry.
Stop the for loop and magically becomes O of n. Oh,
Ooh.
I like that idea.
But how do we? Okay. How do we remove it though? If we remove the for loop, hmm. Hmm.
So what's the for loop doing?
The for
It's
loop,
waiting. It's gonna
it's
shift.
just
It's giving us more. How do you say? It's like brute forcing the shift,
yeah.
the options, the possibilities. So once we're done with the first set, it's gonna move over one, and then it's gonna do it again, I think, or it's gonna do what it can, and then once this one's done with the for loop, then it's gonna go up here, and then it's gonna go here, and then it's gonna break it down, and it's gonna go here, and it's gonna break it down if it can. So that's what the for loop is for. How I think we solve problems that where we do that brute force approach, but this time we didn't use a for loop, and I think that was with a pointer.
Yeah, yeah.
We move a pointer. Now that'll still be the same thing. What is it? Yes, please. We need some hints because I gotta go do some stuff, and the title says we're not stopping the
We
stream
gotta
until we
finish
solve
one.
it. Until we solve something, so we need all hands on deck right now.
All hands on the wheel.
Please.
Okay. So I like the pointer part, right? Why do we send an index?
With memoization. Oh yes.
Okay, memoization. True. Mhm. I'm not. Oh, fast. God, it's thinking now.
I think I got it. Possibly.
Okay, go for it.
So so if you have a pointer, I'm gonna do blue. Blue, you have a pointer right here. Okay? It's gonna do everything from the pointer to the end. Once that's done, right? Once it does all that and you store all of the values you got from here, like you said, oh 6 6, that's gonna return false, or you're gonna return nothing. 6, you're gonna return 1. Then you move the pointer, and I'm talking about this top case right here. I'm talking about this right here. So you move the pointer to 6, and then remember it goes all from the pointer to the end. So it gets 6 6. We already did 6 6. So it's not going to do anything. So all we know that that's false. And then, right, if it's false, that means that means the whole thing is
Mhm.
false.
Mhm.
So then now it moves to the next one, which I don't think that's even needed. But you move to the next one. Actually, it is needed, yeah. And then we already have 6 stored. And remember, this is a whole thing or whatever. This is
Mhm.
2 6
Mhm.
as a whole, and then that's our restart. Something like that. I don't know. Maybe, possibly,
Okay.
maybe, possibly, maybe, possibly. Oops.
Oh, fast. I'm not sure. Because this pointer would serve as the for loop as well.
It will, but it's not gonna. It's gonna check the memoing. You have to do 2 calls.
But how
One
would
of.
be the memoing be?
You have to do 2 calls. One of size n-1 and another one of n-2.
-2. Hmm.
Talking about hints. There should be hints in the problem. Nope. Alright, perfect.
Okay, I understand why is -1, -2 because of the numbers. Because we can have 3-digit numbers. So let's say we have
Jose's thinking. Jose's thinking.
I'm seeing.
Hint 2. Oh, we got a hint 2. Alright, come on, come on.
And two,
Consider
woo,
2
but
cases. In one case, you have that S at I is valid. How many decodings do you get? The second case, you have.
is I times 10?
Excuse me?
Is I times 10? If the second case you have that S times 10 plus S plus 1 is valid, how many decodings you get? Damn. That's I times 10. Hmm.
You got me there, Chief. Man, you know what I'm thinking of right now?
Some burrito, bro.
Nice burrito.
Damn, bro, you got addicted to the burritos.
A good burrito. 2 burritos. We might need to use some inspiration.
No, 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 no.
I only have so much time left.
We only have so much time left.
What's going through your head?
Just trying to understand this memorization thing. Man, I mean, you're down. We can call up Jorge, because I know he got finals. Ufas. Jorge with another
We might need to get him to join the call. Assistance.
assistance. We gotta ring the phone.
Wait. We might have sent the solution already in Discord.
No way.
Yeah.
Oh.
That was over an hour ago.
Oh.
Over an hour ago, you sent the solution.
Damn.
And we've been here for the past 60 minutes. Scraping.
In case one is valid, if yes, then you have the solution for 1, 2, 4, 5, 6. If 2 is valid, if yes, then you have the solution for 3, 4, 5, 6. Okay. Let's see a solution. Damn. If 1 is less than or equal to the int of s minus 1, I was return 0.
What are you looking at?
I'm looking at the solution over here.
Hey.
No, not the solution. Jorge's solution.
Okay.
Yeah. Okay, I know why the times 10. The times 10 is to the decimal places.
What the?
Bro, Jorge is crazy, bro.
Almost there.
Okay, I see. Damn, Jorge, bro. Jorge is freaking crazy, dude. Okay. So, Rini, by the solution, I mean the number of encodings for 2, 3, 4, 5, 6, and the number of encodings for 3, 4, 5, 6. Man, bro, we have to come up, bro. We gotta
Your
lock
mic
in.
changed. Your mic changed. Oh, you can't even hear me. Can you hear me? No way. Hey. Can you hear me? You can't hear me. Jose. This guy. See if I can message him.
Damn, bro.
Yo,
What you
your mic.
think?
Oh, hello?
Can you hear me now?
Yeah. Yes, I hear you now. Oh, my thing disconnected, bro. What the heck?
That's funny.
I'm back though. I'm back. Oh man, bro. Okay,
Ah, you
so
want? Well, Jorge, you know what? I would be down to think through it, man. But you know, I have some other plans today. Okay, and I have to go 100% to those plans. If I don't have enough time,
yes.
I'm cooked. We might need you. We might need you to give us assistance through a call for sure.
Yeah. So if
Please,
you're
of
down,
course.
Jorge.
Please, of course.
Of course, of course, of
If you
course.
don't want to, that's okay. You've been a great help already.
Yeah, yeah.
There's not a girl. There's not a girl involved in those plans. No, there's not.
Then think through it. Oh, imagine, bro.
Imagine.
It's gonna make you think.
Let's get him in here. Where's he at?
Let me see. Let me see. Let me see.
Yeah, join the voice channel.
Is
We'll
it
drag
unlocked
you in.
though?
I'll drag him in.
All right. So, ladies and gentlemen, just a quick introduction to Jorge Cáceres. He's a dear friend of mine from high school and middle school. Right. He's a great friend. He's very smart. You know, and he's gonna help us out. So we'll see how it goes. See how it goes.
Bringing him in.
Jorge,
Hello,
Jorge,
hello, hello, hello.
Jorge, Jorge.
Jorge, Jorge. I can't roll my R's, man.
Me neither.
I don't have
It's
permission
okay.
to talk. Oh, let me change
Oh.
that real quick. Why'd I do that?
Let's see. I think he should have.
Okay, how about now?
Maybe because he's not given a member.
Let me do something real quick.
How you doing, brother? You got it?
Working on it, working on it. I'll just move to the other chat then.
Yo, yo, yo.
Yo, 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 yo.
Yo, 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 yo.
We're here.
Can't hear him. Maybe, maybe, maybe.
Okay, he deafened, he deafened.
Oh, he's deafened. Okay. Fair, fair, fair. Give him time. Oh, he doesn't have permission to talk in the server. Is there a way to give him like privileges?
That's what I was trying to do, but it might be like a. Let's create this.
Hello?
Hey.
There we go. Hello, Jorge.
Okay.
How you
It
doing, my
works.
guy?
Hello, man.
Yes. How you
It
doing?
works only if I do push to talk.
What
Oh,
the?
yeah. Okay.
So I have to be pressing my keyboard in order to talk. So sad.
That is sad.
All right, let me present you, Jorge. This is Carlos from school.
How you
Carlos
doing?
is
How
my
you
best
doing?
friend. Jorge,
Hi, Jorge.
nothing for a while.
Y'all play Fortnite together?
No,
I don't
no.
play Fortnite. I only play
He,
Minecraft.
Oh,
he
okay.
plays Minecraft. He plays.
All right.
He's a beast in Minecraft.
Of course.
Give us a
So
rundown, man.
All right,
We're
buddy.
struggling.
so what I was trying to explain is that for this algorithm, you gotta focus mainly on the okay, so how can I break this through? Okay, so
You could join the Skelejaw as well. If you
Yeah, I'll send it over.
what is that? Okay,
or you could
It's
draw.
like a online website
okay.
to draw and stuff, like a whiteboard. How do
The
I
only
send it over to you?
the
I'll
only
send it
problem
to.
is that I won't be able to use the whiteboard because I have to be pressing the key to talk.
Okay.
Uh
Because like right now, I mean,
Here, try to change push to talk. I think you could talk now if you
okay,
try it. Nope, maybe not.
If you go
Yeah,
to
I
the
guess
mic,
not.
Jorge, it says on input mode, it says push to talk or voice activity. Some technical
no,
difficulty.
it's because the problem is in the server I don't have permissions to not be in push to talk.
Oh,
Okay,
okay.
that's
Um,
weird. That's because I added permissions for you, like to talk and stuff, but I don't know anything about push to talk thing. But that's all right.
Then
We'll just do with it.
it doesn't let me talk unless I press the key, at least on this server.
okay, okay. Oh,
We could
fast.
move. We could just do an individual call.
We can do that. Yeah.
All right, add us to one.
Alrighty. Yes, I got you. Let me. Okay. Let me give me a second. Let me just get out of from here.
Okay.
I'm gonna add Jorgito. There we go. Hello.
Back. Oh,
Hello.
hello.
We cannot hear you, Jorge. Is this alright, guys? Yeah.
Yo.
Oh no, Jorge is having some technical problems. Hello? Jorge? Uh, yeah.
All right. We might need to divert.
Divert. Oh no. No, it's alright. No
Did y'all
worries.
want to go back to the other one, or?
I mean, your call, buddy.
Well, I don't know what his issue is. If it might just
Yeah,
work in the other server.
maybe. Yeah. We can go back, and he can just explain us what to do.
All right.
All right. I'll meet you in the other one. Alrighty. So let's just stay here, cause at least this one, Jorge can talk in here.
Hello?
Hello. There we go. We can hear you now.
I have probably not the best quick solution. What if you guys give me admin for like temporarily on the server?
Well, that's the thing. I gave you those permissions. So
And
that's
it
why
didn't work.
yeah, no, that's why I'm kind of confused.
I'm also confused. Okay, this makes no
Yeah.
sense. Okay, anyways. So wait, let me try again.
No.
And you can just stick to the push to talk.
Yeah,
That's fine.
that's fine. No worries. We good.
Okay. As I was explaining, so in the solution, this is gonna be so hard to explain without visuals, but it's okay. Um, for the solution, what I recommend you guys to do mainly is not so much a counter in that way. Because like the main principle behind. Okay, can you can you guys hear me?
Yes.
Yes.
Okay. Let me just try something else real quick before.
Oh, he's up here.
Yep.
Okay, I tried one last time to talk without the push to talk, but it didn't work. Can you guys hear me in the end?
Yep.
Yes.
The solution that I was talking about, uh, it doesn't have a counter, but it kind of does in a way. So it relies in the principle of what recursion is all about. In recursion, you just assume that you have an algorithm that works already, right?
Yes.
Yes.
So like you're assuming you have the problem already solved. In this case, what's
Okay.
the problem? The problem is just counting the number of ways in which you can decode the string.
Okay.
And the way to do this is to try to simplify this into sub-problems. So the way that my algorithm did it is that suppose we have the function that already works. Let's call it, I don't know, t. I call it t in my written solution, which by the way, I'm not able to send on the disk. Wait, now I'm able to do it. Okay, wait, well, let me send you guys a file so you can follow my thoughts. I wrote it on LaTeX. Wait, hold on. Let me show it to you guys.
Yes. Okay. Oh man, bro, I'm hungry, bro.
Okay, check the coding help channel. I sent something.
Yep.
Okay.
Yeah.
I sent a small PDF explaining mathematically what I'm gonna be explaining right now.
Okay.
So basically, in this solution, you're gonna see uh, two cases. So in this case, what T of I represents is just T of I in this document just represents the solution for the whole string starting at index I. So like
Mm-hmm.
we ignore the previous elements. You just focus from I and whatever comes next. I to the end, basically. Um, to do the recursion, of course. And what I found out is that if you want to compute T of I, which in this case T of I is just the number of ways to decode the string from I to the end, you can do it in terms of T of I plus 1 and in terms of T of I plus 2.
Mm-hmm.
And you might be wondering, okay, why does this make sense? How is this possible? So the reason why this makes sense and the reason why this is possible is because in the case where you're adding T of I plus 2, I mean T of I plus 1, which as a reminder, T of I plus 1 is just the number of ways you can do it starting at the index I plus 1, which, oh my gosh, it's so hard to explain with that drawing. Um, but like, are you guys following me?
Yes, yes,
Yeah.
yes.
Okay. So suppose we want to compute T of 0, which in this case, T of 0 is what we want to compute. Because T of 0 is just the whole string. So like the solution for the whole string. So let's say the string is the numbers 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Mm-hmm.
And we are just gonna focus on the first index, the number 1.
Mm-hmm.
The question is the number 1 valid or not valid? Which in this case, it is valid. Like
Okay.
the number 1 is something that can be decoded. In this case, it can be decoded into a number A. So yeah, it's valid. So it works. What do we know about the fact that it works? How many ways can we do it? Well, we assume we have a working algorithm. Since we have a working algorithm, we know that the solution has to be something something plus the number of ways we have in this case. And what is that number of ways? The number of ways is the number of ways from 2 all the way to 9. Why? Because we know that all of those work. So we have number 1, we know it works. So we have the solution of 2, 3, 4, 5, 6, 7, 8, 9, and whatever we get, we add it to the count.
So we get a total of 9.
No, we don't
No?
know the total.
Okay.
The possibilities, right?
Yeah,
Okay,
yeah,
okay.
we don't know the total. Right now,
Okay, okay, okay.
we're just adding stuff to the variable count. I mean, to the variable counter. So if the string at or the first one, which in this case is 1, if the first one is valid, then to the counter we are adding the solution of the rest.
Yes.
Because we have so many ways of like combining the rest. We don't care about them. We just know it works, because that's the main purpose of recursion. And the main purpose of recursion is just assuming that the algorithm works. So since we're assuming that the algorithm works, well, we're just gonna add it to the counter. But that's not the only case we have. We have also another case, because we have 1, 2, 3 all the way to 9. 1 works. It can be decoded. But also the number 12 can be decoded.
Yep.
Right? Since the number 12 can be decoded, we also have to consider that case. And what's the value going to be equal to? Well, if we have the number 1 and the number 2 being decoded as 12, now we have to focus on the solution for 3, 4, 5, 6, all the way to 9, and add it to the counter. So we add 2 values to the counter. We add the value for the case in which 1 is decoded, and we got the value for the case in which 12 is decoded. And that's the value of the counter. There's no need to do any for loop. You just use the magic of recursion, assuming that the whole solution works. I don't know if what I say makes sense though. It's so hard to say it without visuals.
It's good. It's outside. No worries. No worries. Ufas. Okay.
So I get you. I'm looking at case 2 on the practice problem. It says I to I plus 2. That's 1 and 2 you're talking about, like in that example? That's 12, is what you're saying?
Yes, that's 12. Because
Okay.
I'm using Python notation. I don't know which language you guys are using in the
Yes.
Python. Okay, in Python notation, the first index is included and the last one
And
is not
excluded.
included.
Okay.
So it goes 1 to I plus 1. So in this
Okay.
case, yeah, it's 12. It's the
Nice.
1 and the 2. That's what I did in my solution that I wrote on the document. And the solution that I wrote on the coding hub, like the actual Python solution,
Uh-huh.
you can see how I did it by converting the string si plus si plus 1, which is just concatenation in Python. You're like adding two strings,
Mm-hmm.
they're getting concatenated. You convert it into an integer, and to verify that it's valid, it has to be within range. So in this case, it has to be within 10 and 26. Uh, because we cannot have a two-digit number that's not below 10. So it has to be between
Yeah.
10 and 26. For the other case, because in the coding answer, you can see it. I have A and B. For A, in my code solution, A just represents the case in which the integer at s index I is valid, and B represents the case for which the string si plus the string si plus 1, so like the concatenation of both, is also valid. So you have those two cases because you can only have two digit numbers because, I mean, of course, you don't have over 100 letters, so you only care about
Mm-hmm.
these two cases. And I think that's pretty much it. The only thing that's left is the base case, because of course, without a base case, nothing works. Um, the base case is just that in the end of the list, you have a list of size 1, and a list of size 1 is very easy to verify. All you have to do is to make sure that it works. How do you do it? Well, you make sure the last number is not 0. If the last number is not 0, then it works, of course.
Okay,
Because
that makes sense.
one through 9 can be decoded, which is something that I brought in my code as previous. That's the name of the variable that I gave it. Previous. Previous is 1 only when the last string is not 0. And the last one, the other base case, because there are two base cases. And the reason why there are two base cases is because this depends on I plus 1 and it depends on I plus 2. So we need two base cases in order for this to work. Um, for the last base case is when the string is empty. This is a little bit counterintuitive, but when the string is empty, there is exactly one way of decoding it. Um, the intuition behind this is that we are counting the way of not decoding anything. So like
Okay,
there's only one way of decoding anything, which is by not decoding anything. So there's
fair
only one
enough.
way. So when doing the empty string, there's one decoding. When doing a string of length 1, you just verify it's within the range 1 through 9. Those are the base cases. So once you
Okay,
have the base
fair.
cases and you have the recurrence, which the recurrence is just adding those two values, you're done. That's the whole algorithm.
Okay, that's very interesting. I would have
Yes,
never thought
sir.
about that. I would have never thought about that.
What's up, Kool-Aid?
That's good, bro.
You been up
Hey,
to?
what up, brother? How you doing, my guy?
Doing good. Dude, I have finals tomorrow, and I'm slacking so hard.
It's all good, man.
All good, my guy. But damn. Okay, cool. Okay, that's some next level stuff, dude.
Well,
Um,
I'm honestly down to just run this. If it works, I'm out of here. I need to go. I need to go ASAP.
yeah, cause I know you got some stuff to do, Carlos. So,
But
all right, let's run it,
I
my guy.
think you explained. Let me see. Let's see. Let's see.
Okay.
Okay. Do I dare submit it, Jorge, or no?
Yes, I submitted it and it worked. So
Okay,
Okay.
let me see. Let me see.
Yes, sir.
Wow.
Bro, on the top, bro. Hey, Jorge, thank you very much, brother. Thank you. Appreciate your time. I know you got finals too. But
No worries.
appreciate your time to coming in and spending some time.
I'm
And
definitely
but
gonna
yeah,
revisit like the stream and rehear what you just said because I know there was a lot of value in that. I didn't get to
yeah,
catch everything, but
yeah,
um, I just think I'm desperate on time right now, so I
yeah,
just needed.
It's okay. I could like explain it better with a whiteboard, but right now, I mean, I
yeah.
can't.
No, that makes sense. No, I get you. I get you. Hey,
There'll
but
be
thank you
another
for the
time.
effort,
There'll be
though.
another time where
Thank you for the
we'll get it all
effort.
figured out.
No worries.
Yes, sir.
All right. Well,
Alrighty.
we're gonna end it off right now in a bit. So
Yes, sir.
uh, we're gonna go into the other channel.
Yes, sir.
World.
Thank you. Thank you. Thank you.
Thank you. All right. So, first of all, I want to thank again Jorge for coming in, taking us through this, for explaining it here and there. If you guys don't know him, make sure to you know, give him thanks or give him a shout out in the chat, right? But yeah, he has, Jorge's on another level, bro. I would have never thought about that.
Yeah.
He's crazy like that. He's crazy. He's a genius, you know.
I'm
But
excited. I'm excited to see like to break it down a little bit more when I have time.
yeah, yeah. But nah, thank you, Jorge, again. Thank you. And I know Kool-Aid joined the VC, so thank you for tuning up, bro. Thank you. Sorry for we weren't able to talk that much, you right? But I know Jorge and Kool-Aid had some finals going on. Wish you the best. Stay safe. Stay strong. Almost there. One more week and we finish. One more week and we finish. So keep on grinding. Keep on staying on the task, on the grind. You guys do pretty good. I'm sure of that. You guys do fine. I know Carlos has a time rush, so I don't know. You got
Yeah.
anything to
Nope. I
say
don't got
about?
anything to say. We're
No?
gonna stream on Thursday again.
Yeah. Stream on
We're
Thursday,
streaming on
probably
Thursday
late
again.
at nightish, probably. But yeah. So I got nothing to say. I don't think you got nothing to say, Carlos. Just to confirm.
I'm good.
All right. So thank you guys for coming in. Thank you guys for tuning in. Wish you the best. Great day, great night, whatever it is. And for you guys taking finals, take care, stay safe, stay on the grind. You do fine. I know that. All right, guys. So thank you for everything. Peace out and bye bye.